Bismillahirrahmanirrahim. So today's topic is vibration of air column. At first, if I want to give you an idea, see how we play flute. Flute মানে বাঁশি। বাঁশি বাজানোর জন্য আমরা কি করি বলতো? এই যে বাঁশিটা যেটা ওইটার মুখে খোলা মুখে আমরা কি করি ফু দিই, তাই না? We create some kind of vibration, right, within the flute, and some kind of sound is produced. So this is the idea of actually vibration of the air column. Let us go through it. If we blow at the mouth of a clip, clip means actually অনেকে দেখবা যে পেনের মুখ আছে না, এই যে এটা তো এভাবে ফু দিয়ে একটা সাউন্ড ক্রিয়েট করতে পারে, একটা মিউজিক ক্রিয়েট করতে পারে। আমি পারি না, বাট তোমাদের মধ্যে অনেক হয়তো তোমরা পারো। Okay, if you blow at the mouth of the clip of a pen or at the mouth of a small bottle, we hear musical sound. Yes, we hear it, right? The reason of this is that when two oppositely directed identical waves travel in a limited air column, a stationary wave is produced. Now, how a stationary wave is being produced here? You see, whenever you are blowing in the mouth of a bottle, what is happening? You are producing a wave, right? That wave is traveling through the column in the bottle, air column in the bottle, and what will happen? It will reach the other end, and the other end will reflect it back, right? So as a result, another wave will be coming towards you. That is the reflected wave, right? So the wave that you are sending and the wave that is coming as a reflection of the wave, what will happen? They will superpose on each other and a stationary wave will be created. This one we already studied, right? So the reason of this is that when two oppositely directed identical waves travel in a limited air column, a stationary wave is produced. You can check figure 9.13. Okay. Now in musical instrument like flute, clarinet, etc., tone is produced depending on this type of vibration. Yes, the example that I gave at the beginning of the class. When we blow or hold a vibrating tuning fork, as you can see in figure 9.13, they have hold a vibrating tuning fork. That vibrating tuning fork will create a vibration in the air column inside the, let us say, bottle or something. Okay, যেটার মুখে ধরবা সেটার ভিতরে একটা ভাইব্রেশন ক্রিয়েট করবে। So when we blow or hold a vibrating tuning fork at the open end of a pipe, okay, closed at one end, a longitudinal wave travels from A to N through the air column. You can see A point is the open end of the air column and N is the closed end of the air column, and reflected back to A from the closed end, এবং N থেকে এটা কি হবে? রিফ্লেক্ট হয়ে আবার এর দিকে আসবে। Due to the superposition of the incident and reflected wave in the air column, a stationary wave is produced. To produce this stationary wave, two types of pipes can be used. The pipe whose one end is open and the other end is closed, just like the one that is shown in 9.13. Okay. Now there will be another type of pipe in which both of the end will be open, like in some of the flutes you will see that both of the ends are open, okay, but still you are getting some sound. Now it might seem, a little bit of surprising that if the other end is not closed, then how the sound is getting reflected back, right? To get the reflection, the other end must be closed, right? But still there will be some reflection even though the other end is open. We will get to know in a bit, no problem. So let us start vibration of air column in a closed pipe. Closed pipe now, okay? The one end will be open, the other end will be closed. Let us see how it happens. When we blow or hold a vibrating tuning fork, are everyone with me? Page number 556, 9.24 article, okay? Vibration of air column in a closed pipe. So when we blow or hold a vibrating tuning fork at the open end of a closed tube, a longitudinal wave approaches towards closed end. See, we know that sound travels as a longitudinal wave, right? We have been studying this since grade 9, right? But still we show that it is traveling as a transverse wave, okay, because it is easier to show in the diagram using the transverse wave, okay. Using the longitudinal wave, it is difficult to show in the diagram. That is why we will represent the wave as transverse one in the diagram. Okay, it's mean the same, right? Whenever there is an expansion, we can represent it by crest. Okay, whenever there is a contraction, we can represent it by a trough. Okay, so it is the same. Acha. By this time, longitudinal wave approaches towards the closed end, right? That is N end. N is the closed end, A is the open end. Figure 9.14. Okay, the first one. Three figures are there in figure 9.14 A, B, C. Okay, so so one wave we are sending to the N end and reflected from closed end again approaches towards end A, right? N থেকে আবার A এর দিকে রিফ্লেক্ট ব্যাক করবে। দেখো একটা ওয়েভ আসতেছে A থেকে, আবার N এ ধাক্কা খেয়ে ওটা ব্যাক যাচ্ছে A এর দিকে। By this time another new wave approaches towards, we are continuously blowing, right? So as a result, what will happen when I send the first wave, that will go and it will be coming back, and when it is coming back, I have already sent my second wave, right? So as a result, the second wave will superpose on the reflection of the first wave, right? So as a result, they will produce a stationary wave. Okay, so when a stationary wave is produced, antinodes and nodes are formed in the air. We know this already, right? Okay, antinode is when there is the maximum vibration. Where there is maximum vibration, that is antinode, and where there is no vibration, that is node. Okay, so since it is difficult to express longitudinal wave diagrammatically, we express it by the diagram of transverse wave. Yes, I already explained this. Since the N end is closed, so air particles cannot vibrate at that place. True. Okay, N end, that is the closed end of the pipe. Okay, you can see that as it is closed, the air particle does not have enough space to vibrate there, so a node will be created. But A end, the first, from where I am sending the wave, you can see that it is an open end, so air particle has the liberty to vibrate. It has a space to vibrate. So as a result, maximum vibration will be created there, and we will get an antinode there. Okay, figure 9.14a. Do you want me to draw it on the board? I'm not drawing because it is in the book itself. Okay, vibration of air column. In a closed pipe. So as you saw, I'm sending one wave and the other one is coming back. Okay, so here what is happening? Antinode is being produced, and here one node will be produced. This is the open end and this is the closed end. Now if I blow a little bit more strongly, like I put more force, what will happen? Okay, something like this will be produced. You can see there are now two nodes, one node, two node, two antinode and two nodes. Okay, two nodes and two antinodes will be produced. Okay, if I blow with more force. Okay, acha. So since the N end is closed, so air particle cannot vibrate at that place, so a node is always from there. Here we will get always a node, right? Okay. On the other hand, end A is being open. The air particles there get every chance to vibrate, so an antinode is always from there. Yes, antinode is being found it at the end A. For a stationary wave, the tone of the smallest frequency is called fundamental tone. See, this is the smallest frequency. If I want to get a standing wave or antinode, then we are getting one antinode and one node, right? So this is the minimum frequency required to get a standing wave. So this frequency is known as fundamental tone. In this case, there is one antinode and one node. As you can see, one antinode and one node. When I will get at least one antinode and one node, I can say I have created a stationary wave. Okay, so that is the minimum. That is why it is called the fundamental one. This tone of pipe is fundamental tone of all possible overtone. Now, whatever tone I will produce, everything will be greater than that. Okay, this is fundamental. So if I blow with more force, what will happen? I will be increasing the frequency. If I increase the frequency, the wavelength will increase or decrease. Can anybody tell me?
Wavelength will decrease.
The wavelength will decrease, definitely. Okay, we can say this from here also, V equal to F lambda. So V by F equal to lambda. As you can see from here, okay, lambda is equal to, I can write V by F. V is constant, right? Because we are not changing the medium. Every time it is air column only. So if the medium is same, the velocity will be same. So if velocity is constant, I can write lambda is proportional to 1 by F. That means they are inversely proportional to each other. Also, you can see here, okay, this was half of the wavelength. Now the wavelength has got shorter, right?
Yes.
1.5 wavelength is there. Okay, so wavelength will get shorter, and what will happen? The frequency will increase. Wavelength decrease, the frequency will increase. Yes. So as the frequency has increased, so this all will be overtones now. This one is the fundamental tone, and all the rest I will be getting, they will be overtone. Okay. Acha. Okay, this tone of the pipe is the fundamental tone of all possible tones. This is also known as first harmonic. Yes, if you remember the fundamental tone, we used to call it the first harmonic, right? Okay, so if you blow more forcefully, page number 557, second paragraph, okay? If we blow more forcefully, the wavelength of the stationary wave produced in air column of the pipe will be decreased. Yes, we saw the wavelength got decreased. Previously, this was the wavelength. Now, this is the wavelength, okay? It has got shorter. Achha. Then, as a result, what will happen? Two antinodes and two nodes are produced. Yes, two antinode and two nodes are produced, right? Okay. So this is called the first overtone, right? Okay, this is the first overtone. This is fundamental tone. After that, this is the first overtone we are getting. Okay, since the frequency of this tone is 3 times than that of fundamental tone, it is called third harmonic. Now this is something that you need to understand. Okay, let us say to get this one antinode and one node, I am having to create X frequency. Okay, then if I keep on increasing the frequency until the frequency becomes 3 times of the fundamental tone, I will not get two antinode and two node. There is a practical experiment actually regarding this. I did this in my college life. If we have the the equipments in the laboratory, then we can do in our lab also. Okay, inshallah, I will try to do. So you will see that until you increase the frequency to until you triple the frequency, you will not get the first overtone. Okay, so as it is 3 times of the basic frequency, that means the fundamental frequency, then this is the third harmonic. Okay, because this is third multiple. If you remember, if the fundamental tone is multiplied by 2, then that is second multiple. Okay, sorry, second harmonic. Now it is being multiplied by 3, so this is third harmonic. Okay, anybody anytime can raise hand if you are not understanding any topic, or you are having any question or doubt. Where is Irfan today? ইরফান নাই আজকে, এই কারণেই অনেক কোশ্চেন কম হইতেছে মনে হয়। আব্দুল, কিছু বুঝতেছ? আব্দুল ঘুমাই
জি স্যার।
ও তাকিয়ে আছে, শাবাশ। Okay, fine. Okay, so then, so understood that this is third harmonic. Okay, to get two antinode and two node, I have to increase the frequency thrice. Okay, so this is the fundamental tone. Okay, fundamental tone frequency, if it is X, then I have to make the frequency triple to get the first overtone. So as it is multiplied by 3, this is third harmonic. First overtone but third harmonic. Okay, acha. Now again, okay, if we blow more forcefully, then what will happen? More antinode and more nodes will be produced. One node, two node. Oh, I'm going to বেশি এঁকে ফেলছি না? আচ্ছা, okay. Let us say our air column is up to this. So 3 nodes, 3 antinode, and 1, 2, 3 nodes are there. একটু বেশি এঁকে ফেলছি, এটা আসলে এতটুকুই ব্যবহার করতে ছিল, আমি জাস্ট একটু ছোট হয়ে গেছে। ওকে, অসুবিধা নেই, তারপরে তোমরা মেইন আইডিয়াটা বুঝলেই হবে। we are getting, see এখানে আমাদের ছিল একটা অ্যান্টিনোড, দুইটা অ্যান্টিনোড, একটা নোড, দুইটা নোড, এখানে তিনটা অ্যান্টিনোড আর তিনটা নোড, রাইট? তো এইটা আমরা কখন পাবো জানো? যখন আমরা ফান্ডামেন্টাল টোনের ফ্রিকোয়েন্সির 5 টাইমস ফ্রিকোয়েন্সি ক্রিয়েট করতে পারবো। So can anybody tell me, this is second overtone, right? This is first overtone, this is second overtone, but which harmonic?
Fifth harmonic.
This will be fifth harmonic. Okay, so fundamental tone first harmonic, this is third harmonic, this is fifth harmonic. Do you find any pattern here? Odd multiple, right? Only odd harmonics we will be getting. If I want to get the second
Sir?
বলো
স্যার ইভেন দিলে কি হবে?
ইভেন দিলে, যেটা ইভেনটা এখানে না, ইভেনটা আমরা পাবো হচ্ছে ওপেন পাইপে। ওপেন পাইপেরটা যখন ক্যালকুলেট করবো না, তখন দেখবা কি জানো, যে ফান্ডামেন্টাল টোনের ডাবল করলে আসে, তারপর ফোর্থ টাইম করলে আসে, এভাবে আসবে, ঠিক আছে? তো ওইটা ওপেন পাইপের জন্য। এটা ক্লোজ পাইপে শুধুমাত্র আমরা কি করব, এই যে অড মাল্টিপল গুলোর জন্য আমরা ইয়ে পাবো, বুঝতে পারছো? অ্যান্টিনোড এন্ড নোড পাবো। ওকে, দেখো, again if you blow the pipe even more forcefully, second overtone will be formed. This is our second overtone, okay, and we will get 3 antinodes and 3 nodes, as I already showed you. Since the frequency of this tone is 5 times than the fundamental tone, it is called fifth harmonic. Okay, so if we blow the open end even more forcefully, third, fourth, etc. overtones will be produced. First overtone, second overtone we already saw, then we will be getting third overtone, fourth overtone, fifth overtone, and they are going to be, you know, after fifth harmonic it is going to be seventh harmonic, ninth harmonic, 11th harmonic, it is going to be like that. Okay, so it can be shown above, as shown above, that their frequency will be 7 times, 9 times, etc. Okay, so in closed pipe only the odd harmonics of the fundamental tone are obtained, or in closed pipe the frequency of the overtones are odd multiple of the fundamental. We already saw that, right? It would have been better if I could show you through a practical experiment. Okay, inshallah I will try when the school reopens, if we have the air column. Okay, so this is vibration of air column in a closed pipe. Now let us try to go through, you know, vibration of air column in an open pipe. Okay, both ends are open, as you can see. So even though both ends are open, still there will be some reflection. Okay, why there will be some reflection? Because even though it is open, at the open end there are some air level, right? I will show you. Now at the open end there is air level, right? You see. Okay, so as a result this air level, you know, will act as the reflector, but not as good a reflector like the closed pipe. In a closed pipe this part is rigid, right? Rigid মানে হচ্ছে খুবই শক্ত, এখানে এসে রিফ্লেক্টেড ব্যাক হওয়ার অন্য কোনো উপায় নেই। বাট এখানে যেটা হবে, যখন এই ওয়েভটা আসবে না, এই যে মনে করো এই ওয়েভটা, সরি, এই যে ওয়েভটা এখানে আসবে, এখান থেকে কিছু ওয়েভ বাতাসের মধ্যে হারিয়ে যাবে, বাট অল্প একটু পরিমাণ এই যে এয়ার লেভেল আছে না, এটা থেকে ধাক্কা খেয়ে আবার চলে আসবে। সো আর একটা রিফ্লেক্টেড ওয়েভ এখানে ক্রিয়েটেড হবে লাইক দিস। ওকে, আমি এবারও এখানে আসলে বেশি আইতে দিচ্ছি, তাহলে এরকম হওয়ার কথা না। এটা আমি ফার্স্ট ওভারটোন আইতে করছি। আচ্ছা যাই হোক, আমি মুছে আবার দেখাই। বাট বুঝতে পারছো তো না যে এয়ার লেভেলের কারণে কি হবে, কিছু পরিমাণ ওয়েভ বাতাসের মধ্যে চলে যাবে আর বাকি কিছু ওয়েভ ব্যাক আসবে। তো যেটা ব্যাক আসবে ওটার জন্য আসলে স্ট্যান্ডিং ওয়েভ ক্রিয়েট হবে। এখন দেখো, যেহেতু বোথ এন্ডস আর ওপেন, সো বোথ এন্ডে কি হবে, অ্যান্টিনোড ক্রিয়েট হবে, রাইট? মাঝখানে শুধুমাত্র একটা নোড ক্রিয়েট হবে। Okay, now if you increase, so in this case this is the fundamental. Okay, let us say the frequency of the fundamental tone is x. Now if I increase, then what will happen?
তিনটা অ্যান্টিনোড আর একটা নোড, দুটো নোড আসবে।
One antinode, two antinode, three antinode, and two node, right? And to get this one, I have to double the frequency of the fundamental tone. Okay, so next if I keep on going like that, okay, so it will come, you will see that I am getting fourth. Okay, this is second harmonic, it will be fourth harmonic, so I will continue like this. Okay, the number of antinode and node will increase from here to here. The figure is already given in your book. Okay, so it is clear, I guess. So there is nothing much to explain actually here. You already know what overtone and second harmonic or first harmonic is. Okay, at the second harmonic, this is also called octave, right? This is octave. Okay, so I would like to request you to go through the paragraphs. Okay, there is not much mathematical calculation, so kindly go through this article and let me know if you have any doubt. I will give you 5-minute time. Okay, সবাই একটু খেয়াল করো। ওপেন এন্ডে আসলে আমরা শুধু ইভেন নাম্বার না, আমরা সবগুলোই পাবো। এটা হবে কি থার্ড হারমোনিক। Okay, it will be actually third harmonic. Okay, in open end, this will be the fundamental tone, this will be the octave or first overtone, or we can say the second harmonic, third harmonic, fourth harmonic. That means in open end we will be getting all number harmonic, like not only even, not only what do I say, not only odd, not only even, I will get both odd and even multiple. Okay, if you go through the second paragraph, first paragraph of 558 page, it is clearly written. Okay, if you blow the if you blow the pipe even more forcefully, the second overtone will be produced and we will get 4 antinodes and 3 nodes. Since the frequency of this tone is 3 times, so we are getting third harmonic. Okay, so here I will be getting third harmonic like that. Similarly, it can be shown that the frequency of other overtones are 4, 5, 6 times. That means there is no, not only even multiple, this is for all. Acha, so so we can say that in open pipe both odd and even harmonics of the fundamental tones are obtained. Okay, fundamental tone, even, odd, all are obtained here. Okay, in the open pipe. For this reason, the tone produced from a flute open at both ends are more pleasant to hear than the tone produced from a flute open at one end. Okay, তো এখানে যেটা বলছে যে both end open এরকম ফ্লুট যদি থাকে তাহলে সেটার সাউন্ড শুনতে বেশি প্লেজেন্ট compared to the flute which is closed at one end and open at one end. Understood? তো এক সাইড, দোনো সাইড যদি খোলা থাকে তাহলে বুঝতে আমাদের আরো বেশি ইজি, সরি আমাদের শুনতে বেটার লাগে সাউন্ডটা ওই ফ্লুট থেকে। I hope this is clear. Anybody has any doubt? That is the end of this chapter. Okay, so I hope you already went through the numerical examples that are given in the textbook, and now I'd like to request you to go through the creatives, board exam creatives and other creatives from the suggestion book, and let me know. This is Thursday, so I hope you can practice during the weekends. Okay, try to practice as much as possible so that you can ask me as much as doubt. Okay, Irfan, তুমি আজকে অনেক দেরিতে জয়েন করছো, ব্যাপার কি?
স্যার মাত্র ঘুম ভাঙছে আমার।
ও, আই ক্যান নট ব্লেম ইউ। আমার নিজেরই উঠতে কষ্ট হয়ে যায়, 10টার সময় হোক ক্লাস হইলেও আমার উঠতে কষ্ট হয়ে যায়। আচ্ছা, ওকে, যাই হোক। সো ঠিক আছে, তোমরা সবাই তাহলে ইয়েগুলো সলভ করো, সাজেশন বুক থেকে ক্রিয়েটিভ গুলো সলভ করো। আর যদি ডাউট থাকে ইনশাআল্লাহ তোমরা সানডে যদি বলতে পারো সানডে, অর এলস অন মানডে উই ক্যান ডিসকাস। ওকে, যদি সানডের মধ্যে তোমরা শেষ করতে না পারো, দেন সানডে ইনশাআল্লাহ উই আর গোইং টু স্টার্ট আইডিয়াল গ্যাস। Okay, the last chapter, ideal gas and kinetic theory.
ক্লাস
And inshallah on Monday, Monday the class 9, Tuesday class 9. So on Wednesday inshallah we will discuss about your doubts regarding the creative of this chapter. Web, okay? হ্যাঁ, বলো।
স্যার কালকে কখন ক্লাস?
কালকে কালকে কি আর করবা তাইলে? কারণ হচ্ছে এই চ্যাপ্টারটা আমি ভাবছিলাম আরো 2টা ক্লাস লাগবে শেষ করার জন্য, হয়ে গেল। কালকে যদি ক্লাস নেই তাহলে আমরা আইডিয়াল ক্যাসটা শুরু করবো আর কি। তোমরা কি আইডিয়াল ক্যাস শুরু করতে চাও এখন, নাকি ওই ইয়াটা শেষ করবো আগে?
স্যার বেটার আমরা সাজেশন গুলো দেখবো।
আচ্ছা, ওকে, যদি চাও তাহলে কিন্তু আইডিয়াল ক্যাস আমি শুরু করতে পারি, আমার অসুবিধা নেই।
ওকে স্যার।
আচ্ছা, তো তাহলে আমাকে হোয়াটসঅ্যাপে দ্রুত জানিও যে কি করবা। ওকে ওকে, থ্যাংক ইউ ভেরি মাচ ফর জয়নিং। আসসালামু আলাইকুম ওয়া রাহমাতুল্লাহি ওয়া বারাকাতুহু।